Hello friends, have a nice day. This is Professor Dr. Gajanan S. Wajire from Department of Electronics, Sri Shivaji College of Arts, Commerce and Science, Akola. Friends, today's topic for discussion is oscillators and Barkhausen criterion. Any electronic circuit that generates AC signal with constant amplitude and frequency is called as an oscillator circuit. However, to generate AC voltage from the oscillator circuit, we must provide the DC voltage to the circuit. Thus, by using DC voltage, an AC voltage is produced with the help of oscillator circuit. Oscillator circuits are mainly used in communication electronics and many more applications. For example, in radio, television and mobile communications, for the construction of transmitter and receiver circuits, we ever needs medium and high frequency oscillators. If we talk about classification of oscillator circuits, then we can say that oscillator circuits are classified as per various parameters. They can be classified according to the nature of waveforms, according to the style of producing the waveforms, according to the range of frequency and various parameters they are classified. So first, according to the nature of waveforms, the oscillator circuits are classified into two subtypes. First is sinusoidal oscillators. This oscillator essentially generates or produces sine waves only. And second, it is non-sinusoidal oscillators. This oscillator generates either square wave, triangular wave, pulse wave or sawtooth waveforms. According to the style of producing the waves, oscillator circuits are classified into three groups. First, it is LC oscillators, or they are also called as tune oscillators. Second, it is RC oscillators, and third, it is crystal oscillators. Now come to first type, it is LC or tune oscillators. Here L indicates inductance and C indicates capacitor. This is the most basic type of oscillator, which essentially consists of LC tank circuit. Also it is called as LC tune circuit. It is the combination of single inductor L and a single capacitor C which are connected in parallel as shown in this particular figure. Now as shown in this figure, initially suppose this capacitor C is charged with the shown polarity. Basically, capacitor stores energy in the form of electrostatic energy. Now in this particular circuit, this inductor L, it is in parallel with capacitor C. So the stored energy into the capacitor will get discharged through this inductor in this way. Now this electrostatic energy is converted into electromagnetic energy in terms of inductor. The total energy is stored across this inductor L. Now we can say that again this capacitor is now connected in parallel with the inductor. So the inductor energy now get again convert into this capacitor energy in the form of electrostatic energy, and this time capacitor will charge with opposite polarity as compared to initial polarity. So we can say this time capacitor will charge with positive on this plate and negative charge on this plate. Again in this case we can say that the electromagnetic energy from inductor is converted into electrostatic energy in terms of capacitor. Now again in next cycle, the energy stored in capacitor will get again discharged through this inductor, and later on again it will charge capacitor in its opposite polarity as compared to initial polarity. and thus this interconversion of energy from capacitor to inductor and inductor to capacitor, it continues for the long time. And finally, if we try to take the waveform across this tank circuit or tuned circuit, we get the waveform like this, which is called as damp waveform or damp oscillations. Damp in the sense, initially the amplitude of waveform is somewhat high and later on it goes on decreasing time to time, and after some finite time that waveform goes on die or it comes to end. This happens due to losses in capacitor as well as in inductor. So after every cycle that losses takes place and energy stored get decreased with time. So finally we can say that across this tank circuit we get such type of damp oscillations, and actually we don't want such type of damp oscillations. Instead we want such type of undamped oscillations. Undamped in the sense its amplitude as well as frequency remains constant for the long time. The amplitude of the output waves produced by the tank circuit is not constant. Due to various losses, it increases with respect to time. Such oscillations are called as damp oscillations. These oscillations die out after some time. Hence, such waves are not useful at all in any practical electronic circuits. Therefore, it is necessary to convert it into undamped or sustained oscillations. The specific circuit which produces such a sustained or constant oscillations is called as basic oscillator circuit. Now, in order to have constant oscillations at output, the oscillator circuit needs to satisfy two conditions, and that two conditions are called as Barkhausens criterion. In any oscillator circuit, the damped waves are produced first and then that are converted into undamped waves with the help of other circuit arrangements. These circuit arrangements or conditions are known as Barkhausen criterion. It has two important rules or conditions for a circuit to be used in the oscillator. The first condition is the circuit must contain an amplifier whose gain must be greater than unity. That means the gain AV, it should be greater than 1. Here it is necessary to have this gain greater than unity in order to recover the losses in L and C circuit. And the second condition is the circuit must have a positive feedback. Already we have discussed in detail about positive and negative feedback. Here, positive feedback in this sense, the phase shift should be 0 degree or multiple of 360 degree. In short, we can say that positive feedback means the feedback signal should be in same phase with the initial signal. Now try to concentrate on this figure. In this figure, the LC tank circuit is given by this block. Its oscillations are given to this amplifier. Then amplifier amplify the signal and gives the output as per the specified value. Then some part of this output is connected to this feedback circuit, particularly positive feedback circuit, and this positive feedback circuit, it gives output to this oscillator circuit, so that the input signal and this feedback signal, they are in same phase. That's why it is taken as phase shift of 0 degree or phase shift of 360 degree. In this LC tank circuit, the recovery of that loss in signal takes place, and then again signal it gives to amplifier, and finally we get the fixed output with its fixed amplitude as well as fixed frequency. So let's stop here, friends. Thank you very much.